Alright, so in this section, let's take a look at double displacement reactions, and in particular, let's look at precipitation reactions first. So I'm going to give you the right-hand part of the equation, and then you're going to need to come up with the left-hand part and balance the formula. So let's see, let's do, this is 2 plus because the sulfate's 2 minus and there's only one copper. So these guys are just floating around in solution like that. Same with our silver and our nitrate. So this is what happens when you've got aqueous solutions. These guys are going to come apart. So remember, when we're doing these types of things, we can just double check and make sure, using our ionic form of the periodic table, that we have the right charges for things, right? So we could look up this sulfate, and we could find that first because we know that that's polyatomic. So we see sulfate is -2, so we put that charge there already. And then based on how the copper is bound to the sulfate, it's in the +2 state right now. So now we've got our silver. We can come down and we can see that silver is going to be in the +1 state. Make sure they're all on here. And the nitrate is another polyatomic ion, NO3, and it is a 1-. So we know the charge states for each of our substances, and that's the first thing I want to figure out before I do the rearrangement on the other side. So figure out what your different anion cations are and what their charge states are. And then for a double displacement, you're going to exchange the cations with one another. So the silver is going to want to come over with the sulfate, and the copper is going to want to come over with the nitrate. So if we make our new compounds on this side, the copper would come with the nitrate, and our silver is going to go with the sulfate. So just like when we're making new molecules, we just start out with one of each, and then we evaluate it. We know the nitrate is -1 because we already looked that up. We know our copper is in the +2 state. So these guys are not okay together written like this because their charge state does not equal 0. So we've got to evaluate them and make them 0. And so again, you can do the cross multiplication. So if we have charge on top in this case and number of atoms below, if we do 1 for the copper and 2 for the nitrate, we should get this to balance. 2 times -1 give us -2. 1 times +2 giving us +2. That should neutralize and be a good compound. So we're going to need to have 2 nitrates present to make that a good valid compound. Same thing with this molecule here. We know our silver is at a +1. The sulfate is at a -2. So we're going to end up needing 2 of the silver atoms to be able to balance and make a good molecular compound. So now that we've got our reaction taking place, so we've got copper sulfate in the aqueous form plus our silver nitrate in the aqueous form. This is going to go to the copper nitrate plus our silver sulfate. And we don't know their states yet because we haven't evaluated that. But we do see that we don't have a balanced equation over here. We have 1 copper, that's balanced. We've got 1 sulfate, that's balanced. But I've got 2 silvers over here and I only have 1 over here. I also have 2 nitrates over here and I only have 1 over here. So to balance this guy, we're going to have to change the coefficient on this side to 2 so that we can get balance on both sides. So now my copper equals 1 on this side. My sulfate, we're going to keep that together because it's the same on both sides, equals 1. My silver now equals 2. My nitrate now equals 2 because that 2 goes to both of them. My copper on this side equals 1. My sulfate on this side also equals 1. My silver equals 2. And my nitrate equals 2. and everything balances. So we've got a nice balanced equation now, and now we need to figure out what precipitated. Did the copper nitrate precipitate, or did the silver sulfate precipitate? So we can figure that out by actually looking at our solubility rules. So you can find a copy of the solubility rules from Chapter 5 lecture notes. They are also on the cheat sheet that you get for the exams. So I happen to have them written out. I just pulled one of your exams. And they're actually written out down here on the exams. So I don't know if you can get them close enough to actually read them here. But you could take a look at these guys and then figure out what thing is going to be the solid and precipitate in that solution. So in looking at our equation, we can evaluate copper nitrate. And so rule number 2 of our solubility rule says all nitrates, acetates, and chlorates are soluble. So this guy has to still be in the aqueous state. So that guy is still soluble. So let's check silver sulfate and see where it lines up in the rules. So it says all sulfates are soluble except those with barium, strontium, calcium, lead, silver, and mercury. The latter 3 are slightly soluble. So silver sulfate is slightly soluble, but that means it's likely going to precipitate out of solution, and then we'll see probably a white precipitate with our silver sulfate. So that's a good example of a precipitation reaction. So when you're doing these, if you're only given this side, the first thing that you need to do is do the double displacement. You need to swap the cations, or swap the anions, it doesn't really matter, but pick one and swap them with each other. And then you need to make sure you make the right molecular formulas. So they have to be correct molecular formulas that are going to balance out to a 0 charge state. So you have to make sure that the molecular formulas balance each other, and so you have to make sure that the molecular formulas are neutral formulas that do not carry a charge on them. So once you've made your correct formulas, the next thing that you're going to do is to balance the equation. Make sure that you've got the same number of elements on the left side of the equation that you have on the right side of the equation. Once you've balanced your equation, the final thing that you need to do is look up on the solubility rules and see which component is going to be the precipitate in your sample. So you look up your solubility rules, determine if a product precipitates. That means that it turns into the solid form, and it's going to fall out of solution. So in this case, our silver sulfate is going to be the one that comes out of solution. So that's double displacement reactions, looking at the precipitation reactions in particular. So in the next segment, we'll do another double displacement reaction, but we'll do the acid-base neutralization reaction. So typically too, you can recognize a double displacement reaction is going to have 2 ionic compounds that are involved and they're going to be mixed together, and you're going to be able to swap the cations with one another. So that's one way that you can recognize when you've got a precipitation reaction. The other way is if it's fully already written out, you're going to see that things are in aqueous state, and then one of the compounds will be in the solid state. So when you have changes of phase, this is another way to recognize that you've got a double displacement precipitation type of reaction going on. So this will become a little more clear when we see some examples of the other types of reactions.